Hey everybody, I hope you're doing well. We're going to start the beginning here of the last couple sections dealing with limits. My goal is just to give you kind of a brief introduction to limits so that you're ready when you get to calculus. Calculus is everything is based off of this concept here in the beginning. And you know, when you're in calc next year, they're going to go over this again. So it's not, totally crucial that you totally get it, but I like to give it to you a little bit of information about it. The more you see it, the better it gets. All right, so we're going to introduce kind of the concept here and the notation, and then we'll cut to the chase of just, how do you work with these things? So first thing is here, limits deal with functions and graphs in particular we look at here in general to get started. So here I have a graph, it's a parabola. You can see it's opening down. It's got a point up here, vertex up there at 6. A little hard to see here, but this is 1, 2, 3, 4, 5, 6 there. Okay, so the question is, as x approaches 6, what does f of x get close to? Okay, that might seem strange. So here's our numbers, our x's, and here's our y's. So as I get closer and closer to 6, what is my y? These are my y's. Get closer to. So what I like to visualize sometimes is if I was a little guy walking here, and I'm getting closer and closer. Now here is 6, right? This is where x equals 6 right here. As I get closer to 6, okay, what am I getting closer to and why? And to be honest, for a limit, we have to talk about from both sides. So, I don't know, maybe my twin brother is over here. Oh, that one, the head's falling off. That's horrible. As I go up this graph, what am I getting closer and closer to? What am I getting closer and closer to? As I get close to this line, x equals 6, right? This is x equals 6. I'm getting close to that point. I'm getting closer and closer to y equals 36. So that's what I'm getting closer and closer to, the f of x of 36. So that's what a limit's asking about. Now, it's about approaching, and what do I get close to? What am I going towards? It's not necessarily about what it is exactly. Now, in this case, it would be 36 at 6, okay? If I plug in 6 into this function, I will get 36. But it doesn't have to be, and we'll see that with some of these problems. But I wanted you to see pictorially, just with the picture, what do I mean by a limit? It's about this approaching it from both sides, from this side and this side. What y value am I getting closer and closer to? Okay, now I'm going to give you the formal definition. Don't get scared. Really, the important part is seeing the notation. Okay, so definition of a limit is if f of x becomes arbitrarily close, we'll come back to that, to a unique number L as x approaches c from either side, the limit of f of x as x approaches c is L. Okay, now, what is that saying? Well, what it's saying in the last example, we were getting closer and closer to 36. That's that unique number L as x approached c from either side, as I approached 6 from either side. So we can say the limit then was 36. So here's our notation. Limit as x approaches c of f of x equals L. If I looked at the last problem in notation sense, it would have looked like this. As x approaches 6, and our function was 12x minus x squared, and our answer was 36. So this is notation for what we just did in the previous problem. It's what we asked you to do in the last problem. That's what this is asking you to do. Okay, so as x approaches 6 from either side, my limit was 36. So that's the notation we use. All right, so a couple different ways we're going to do it here in the beginning, and then we're going to talk about some algebraic techniques. Right now, there's only a couple ways we can do this today in this first video, and that is we can do it in terms of a table of plugging in values, or looking at the graph, and we're going to do both. Okay, so when I look at the table idea, what I'm asking you to do, if you can see this, it says, and I don't know why my numbers are so small on my limit. I'm going to make this a little bit bigger. This says is the limit as x approaches 4 of x minus 1. All right. So I'm trying to figure out what I'm getting closer to. So real practical, I'm just going to plug in a table. 3.9 minus 1 is 2.9. 3.99 is 2.99. And 3.999. Technically, I don't really want to know what happens at 4. We'll get to that in a minute. I'm asking as I get closer. So, oops, I made a mistake. You're probably screaming at me for writing that. 2.99. If I go over here and do the same thing, this would be 3.1, 3.01, 3.001. So, as I get closer to 4 going this way and closer to 4 going this way, what does the f of x seem to be getting closer to? Well, you can see it right there. It's getting closer and closer to 3, and that's what my answer is. My limit is 3. I'm getting closer and closer to that 3. Now, in this case here, I actually could have plugged in 4. 4 minus 1 is 3. It's exactly the point. But I'm going to show you by doing it in the next example that that's not necessarily the case. In other words, I don't necessarily care about what happens there. I'm asking what's happening around it here on either side. What am I getting closer to? Because if you look at the next example, the limit as x approaches 2 of x squared minus 4 and x minus 2. If I try to plug in 2, you'll notice you get 2 squared, that's 4. 4 minus 4 is 0. And 2 minus 2 is 0. You get it 0 over 0. You get a 0 on the bottom. We can't do it. There is no answer to this. Okay? So I can't just do that. So I'm going to have to plug in these values. Now, you can take a minute and plug them in. I've already done it ahead of time. So this answer is 3.9. This one's 3.99. This one was 3.999. This one was 4.1, 4.01, and 4.001. Notice, so as I get close to 2 on either side, what is the f of x getting close to? You can see it's getting close to 4. So this problem hits the point home. The limit is about what's happening as I move closer and closer. As I move closer and closer, not about what's happening at the point. Because there is nothing happening at the point. It doesn't exist. There's a hole in the graph, if you remember when we did those earlier in the year. Okay, so that's the idea of a limit. All right, so we have a couple ways we can do this. This is one way, using the table. Okay. Another way, we could create a table with this one, just like that. This is limit as x approaches 2, and I could, make a table the same way I did with the other one. I could say, 1.9, 1.99, 1.999. This is my 2, which doesn't have an answer. 2.001, 2.01, or 2.1. But what I want to do is kind of show you how you can use a graphing calculator for this. There are some online ones. I found one. I didn't go searching for long. The first one that'll do this as well. I'll share the web address with you on the assignment in the video if you like. But I'm going to show you on the graphing calculators how we could do this and use the table feature. It's not so much looking at the graph as it is using the table feature. Okay, so if I go to my TI, I go in here. I already typed it in. It's this first one here. You can see I typed in. Make sure to put parentheses around things so that it's set up correctly. If you want to look at the graph, you can, but really I don't even bother. I'm going to show you the graph. That's what the graph looks like, but that doesn't matter. So we're going to go to the table, okay? And you're going to notice something. So as x approaches 2, so here's 2. Notice there's an error. It's because it doesn't exist at 2. Now we got to figure out what's happening as I approach 2, coming down, going up. But this isn't, it looks like, you might want to take a guess there. Maybe it looks like it's 4. We got to double check. So what we're going to do is change some things in our table set. So what we can do, oops, wrong one, second window, table set. I'm going to 2, so maybe I'll go 1.9, and then 0.1 as my change in table. Change in table is, you'll see what it means. But table start is where am I starting at? What's my number there at the top of the screen? And change in table is what is each x value. So the next one is 1.9, and then it would be 2, and then 2.1, then 2.2. So that might give us a little clearer, better picture of it. Okay. So if I go to my table, okay, You can see, I'm going to scroll up and put that in the center. Definitely looks like we can see that that's going to 4, right? We could even change the table set. And to be honest, a lot of times this is what I choose, is 1.9 and then 0.01 gives a better picture. A lot of times for other ones, this one we could easily see from at 1.9 and 0.1, but not always is the case. And you can see that's going to 4. You can use that table feature to help you do that. Okay, so if we go over here, the answer to this is 4. Again, you could plug in values. It's a little bit more work, or we can just use the graph. All right, so maybe try the same thing. Use the graph to estimate or find the limit. We can type it in. You want to try it on your own, you can first. You could pause it and try it yourself. All right, I already typed it in. I'm going to go to my table. Oh, I forgot. Yeah, the error is at 2. And I already had this set. That's the other thing too. If you kind of keep it, you just have to change where you start, because if this was a limit as it went to like 4, I'd want to change it to like 3.9. So if you look at your table there, I'd like to center my 2. Definitely looks like on either side this is going towards 6. Okay, and so that would be my answer. So that's how we can use the graph and the technology to kind of help us get an answer a little bit quicker. All right, last thing does not involve, for this video, the last thing does not involve the graphing calculator. This really kind of gets to what the limit is, and it's a piecewise function. We'll look at some more of these later as well. But how would I do this one here? So let's see, the graph, f of x is 1 when x is not 5, and it's -2 when it is 5. So what that means is, if I'm not 5, I'm up at 1. So that means, like, here, I'm at 1, 1, 1, 1, all the way until I get to 5. There would be an open circle. And then here, it would go on. But I'm -2 at 5, so here is my point. Okay? All right. So, how am I going to figure this out? Well, let's think about what this is asking. It's saying, as the limit, find the limit as x approaches 5. So if you go back to my beginning problem and think of, little guys walking closer and closer to 5, what's happening? Where are they approaching? What value? What y value? Well, what y value they are always approaching is 1. The answer to this question is 1, because as I get closer and closer, I'm always at 1. I'm at 1, 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 get closer and closer. It does not want to know what's happening right at 5. Right at 5, I'm at -2, but that's not what this is asking. It's really asking you about, okay, what a limit is asking you about is what's happening around it. What's happening in here? Okay, right around that area. As we get closer to it, it does not concern itself with this point itself. I just realized this looks like a Pokemon ball. All right, so that's what a limit's about. Just trying to get you to see that idea. We're going to hit that up a little bit more in some other concepts.